Alright, to solve this quadratic equation, what I'm first going to do is isolate this part that is squared. And so to do that, what I'm first going to do is subtract 3 from both sides of the equation. And then I'm going to divide both sides by 3. Alright, so now I've isolated this squared quantity right here. So what I'm going to do now is I'm going to apply the square root to both sides of this equation. So I'm going to square root this left-hand side and the right-hand side. The whole purpose of square rooting is to attack this squared part right here. The square root of something squared will just give me that thing on the inside, so it's 5x minus 6. Because in essence, the square root and the squaring cancel each other. What's really important is now on the right-hand side of the equation, because this is an even radical that I'm applying, I get this plus minus the square root of 4, which is 2. And what this is really two separate equations. We have one equation which is 5x minus 6 equals 2, and we have 5x minus 6 equals negative 2. And then we solve each of these equations separately to get our two solutions. So adding 6 to both sides, I get 5x equals 8. So x equals 8/5. The second equation, I add 6 to both sides to get 5x equals 4. And so x equals 4/5. So I have two separate solutions, x equals 5/8 and x equals 4/5. And just to recapture the whole concept of what I'm trying to do here, what I do is I take my original statement and I'm isolating this part again. It is squared by attacking this plus 3 by subtracting 3 to both sides and then dividing by this 3 that's being multiplied to it. Once I have that isolated, then I can take the square root of both sides of the equation. When I do that, I always get this plus minus when I use a square root because it's an even indexed root. That is two separate equations. The 5x minus 6 equals a positive 2 and 5x minus 6 equals negative 2. I solve each of those independently to get my two solutions.